What's up, Honors Pre-Calc? We're going to be talking about matrix row operations, which is your last new topic for the 2020 school year. So, matrices are just a way of organizing data in rows and columns, and we're going to be organizing systems of equations in an augmented matrix. All right? So, things that we can do to solve these things, we're basically using elimination to solve these equations. We can swap rows around, we can multiply a row by a constant, and we can add rows together. So through these ways, we can get through and cancel out a lot of these coefficients, and that's kind of our goal. So the goal in all of these augmented matrices is to get it to row reduced echelon form, which looks like this image here on your screen, where you've got ones that go down the diagonal from top left to bottom right, and zeros everywhere else except for on the right hand side of the dotted line. Now the way that works is whatever the number is in that top row, that is your x, the middle row is your y, and the bottom row is your z value. So once you get it to row reduced echelon form, you've solved the equation or the system of equations, and you're good to go. So here's an example that is from Delta Math, and we're going to kind of go through and see what steps we could take to get this to look like that row reduced echelon form. So first step is to get this thing into an augmented matrix. So we're just writing down the coefficients. So as you can see down the left hand column, you have 1, -1, 2. Middle is 2, -3, 4. The right is 2, -1, 5. And on the right hand side for the constants is 1, 5, and 8. So we just transfer those numbers down. And now we're trying to get rid of or cancel out numbers if we can. So same way elimination works, if you see numbers that match, like a 1 or -1, if I add those together, we'll have a 0. So my first operation that I want to perform is adding row 1 to row 2 and putting that in row 2's place. So as you can see, row 1 and row 3 are unaffected. The top is still 1, 2, 2, 1. The bottom is still 2, 4, 5, and then 8. Now the middle row is what I get when I add row 1 to row 2. So all we did was 1 plus -1 gives you that 0. 2 minus 3 is a -1. 2 and -1 is that 1. And then 1 and 5 adds up to 6. So now we're kind of getting into another technique that we need to be comfortable with, is we're using a 1 in that top left-hand corner to get rid of everything else in the column below it. So we've got rid of the -1. Now, as you can see underlined in blue, we're going to get rid of this 2. Because if I take -2 times that 1 and add it back to a 2, we'll have a 0. So that's what I mean by eliminate. I want to turn it into a 0. So my next row operation will be -2 row 1 plus row 3, and we'll put that in row 3's place. So by doing that, row 1 and 2 are unchanged. And then the bottom row, if I take -2 plus 2, I get 0. -2 times 2 is -4, plus 4 gives us a 0. And then -2 times 2 is -4, plus 5 is a 1. And then the bottom right ends up being a 6. So now that actually eliminated two different variables for me. So I have that zeros in the bottom left-hand corner, which is a good sign. We have ones almost on the diagonal. One of them is negative, but we can fix that here in just a second. But now we have the bottom row, we have just a 1 on the right-hand side. So we can use that to eliminate the 1 right above it that I have circled there. So if we put row 2 minus row 3 in this place, then we will have our next set of matrices. So now again, the top row and bottom row are unchanged. All I wanted to change was row 2. So in doing so, of course, 0 and 0 gives me 0. 0 and -1 gives me that -1 in the middle. And then 1 minus 1 is 0. And then 6 minus 6 gives me 0 as well. So now row 2 and row 3 are almost perfect. Row 2, all I have to do is get rid of that negative. So multiply that by -1. And now we're good to go. All right. So now what I have is my row 2 and row 3 are completely perfect. I know that my y will be 0, my z will be equal to 6. So now I need to use these 1s in row 2 and 3 to eliminate the rest of the variables on that row 1. So first, I want to get rid of that 2 I have circled. So if I take a negative 2 times row 2 and add that to 2, I'll get my 0. So that's really where we're headed now. So in doing so, we'll have this end up. So the row 1 turns into a 1, 0, 2, then a 1. And now all we have left is that 2 that is in row 1. And we can do kind of the same operation we just did, but just using row 3's values. So in doing so, we will end up with our row reduced echelon form. Now I have it color coded for you. So as you can see, the only thing to the left of the dotted line is 1s down the diagonal. Everything else is a 0. When this happens, we have our answer. So as you can see, x is going to be that negative 11. Y is going to be a 0. And Z is going to be a 6. Thank you guys and have a great rest of your week.